We're going to continue by the complex form of a homothecy. Suppose you have a homothecy of ratio k and the center omega. So we have omega m prime equal k omega m. So zm prime minus z omega equal k into zm minus z omega. If you distribute and take the z omega to the other side, you have this one. Put z omega in factor. So it's the same thing as we did in rotation, but the difference in rotation we had angle ei alpha here we have a real number k. So a homothecy, the complex form of a homothecy is of the form z prime equal kz plus b, where k is a real number different than 1, and z omega is b over 1 minus k. Let us take the example here. Let H be a homothecy of center W ratio 1 over 3, where ZW center is 1 minus I. Write the complex form. So Z prime will be 1 over 3Z plus Z omega W, which is 1 minus I, into 1 minus 1 over 3. So it will be 2 over 3 times 1 minus I. You have this one. Suppose you have z prime equal minus 2z number 2 minus 2z plus 1 minus I. Find the characteristic. Here this is a homothecy because the product of z is a number which is minus 2, and the center will be 1 minus I over 1 minus minus 2 over 3. So this is a homothecy of ratio minus 2 and center 1 over 3 minus 1 over 3. Now we're going to have the composite of a homothecy and translation. Always homothecy and translation is a homothecy where ratio is the same ratio that you have in H. So the answer, as you can see here, is 2, or vice versa, it's 2. But they will have different centers. In a TV row H is not the same as H row TV. So let us take this example. Given a homothecy of ratio 2 and center omega 1 1 and translation of vector v minus 1 2. First of all, I'm going to do TV row H. So first of all H, so z prime equal to z plus 1 plus I into 1 minus 2. You have z prime equal to z minus 1 minus I. Then you have a translation, so z double prime will be this z prime minus 1 plus 2i. Replace z prime by its value. You're going to have z double prime equal to z minus 2 plus I. This is a homothecy of ratio 2, and center z omega prime will be minus 2 plus I over 1 minus 2, which is 2 minus I. So this is a homothecy. So TV row H is a homothecy in this example of ratio 2 and center omega prime. However, if you want to find H row TV, we start by TV, which is z prime equal z minus 1 plus 2i. Then homothecy z double prime equal 2 z prime plus 1 plus I into 1 minus 2. And if you replace z prime here, which is z minus 1 plus 2i, and you multiply it by 2, you're going to get 2z minus 2 plus 4i minus 1 minus I. So you have a homothecy of ratio 2 and center minus 3 plus 3i over 1 minus 2, which is 3 minus 3i. So as you can see, a translation composite of a homothecy is different than homothecy composite of a translation. Both are homothecies of the same ratio of that we have for H, but they have different centers. Okay. Now something else. However, here you have the formula of the general formula of the homothecy and translation. No need to memorize it, because in problems we need to deduce these directly, not to memorize. Okay. Here we're going to have composition of two homothecies. We have two cases. If you have these two homotheses and the product of the k1 times k2 is 1, like here 2 times half is 1, so we're going to have a translation. We don't have any more a homothecy. Like example in the rotation. In the rotation, if you have angle alpha and the second one is minus alpha, r rho r prime will be what? A translation. We did it in the first chapter, because we have alpha plus minus alpha in a 30 minus 30 degree, which is 0 degree, so we have translation. Here, if k and k prime product is 1, so H row H prime will be what? A translation. Let us take this example. Here we have homothecy 1 ratio 2 gamma 1, homothecy 2 ratio half gamma 2. So I'm going to start by H2 row H1. So H1 will be Z prime equal to Z plus 1 plus I into 1 minus 2. You have this one. Then H2, so Z double prime will be half Z prime half z prime plus 2i into 1 minus half. So half times 2i is I. If you multiply now z prime by half, so you're going to get z minus half minus I over 2 plus I. So you have here, as you can see, a translation, since the coefficient of z is 1 and the vector of translation is minus half half. However, if you do the vice versa, you're going to have the same thing but different vector. So here h2, so h2 z prime equal half z plus 2i into 1 minus half. You have half z plus I. And if you do h1, which is 2z prime minus 1 minus I into 1 minus 2, you have minus 1 minus I. And if you multiply here z prime by this z prime by 2, you're going to get z plus I plus 2i, as you can see here, minus 1 minus I. You're going to have z minus 1 plus I. This is a translation of vector v minus 1 1. So always h1 row h2 not equal to h2 row h1 always, unless they if both of them they have the same center. If both of them they have same center, okay, it works. So they're going to have the same center that for h1 row h2 and h2 row h1, which will be the given center, because if they are the same. However, if k is the product, as we said here, is 1, so we don't have anymore a homothecy, we have a translation. Here this is an example where we don't have a translation, because the product of the case of the homothecy is not 1. Like here you have 2 minus 3, so we're going to have h2 row h1 minus 6. And as I told you, h2 row h1 and h1 row h2, they're going to have different center, unless if these two centers are equal, you're going to have the same one here. So let us take here, I'm going to do h1 row h2 row h1. So we're going to start here h2 row h1. So we're going to start by h1. So z prime equal 2z into 1 plus I into 1 minus 2 minus 1 minus I. Then you have h2 z double prime equal minus 3 z prime plus 2i into 1 minus minus 3 times 4. So 4 times 2i will be 8i. And if you multiply z prime by minus 3, you're going to have minus 6z plus 3 plus 3i plus 8i. So here you have a homothecy of ratio minus 6, and this is the center. Thank you for listening.